All right, guys. Today we're going to talk about proportions. So have open lesson 5-6 of your guided notes to go through. I'm going to go through some of the notes here, the vocabulary at the top, work through the first example problem with you, and then go ahead and complete those practice problems on your own and submit that on the day 6 classwork worksheet assignment. So we're talking about proportions, and a proportion is simply a way to compare two ratios. So we're comparing two ratios, or we're setting them equal to each other in order to find equivalent ratios. So we're using a proportion in order to set two ratios equal to each other. So that's something like 2 out of 3 is equal to 8 out of 12. And we know that just from fraction operations that we've worked on in the past, but we can also say this is like $2 for every 3 apples is the same as $8 for 12 apples, or something like that. And so we've also seen ratios written like this: 2 to 3 is equal to 8 to 12. And then the last one is just kind of written out in words. 2 is to 3 as 8 is to 12, or 2 out of 3 is equal to 8 out of 12, or something like that. And so when we have a proportion, something's missing from this. We have some variable that's missing that we're trying to figure out. So if I'm talking about my example of something like it's $2, let's say $2 for 3 apples. And I want to know how many dollars, X dollars, to get 12 apples. What I'm really trying to do is find this kind of equivalent fraction, set up this equivalent ratio, and we call this a proportion. When I'm trying to solve for this X, I'm using some sort of relationship between this 2 and 3 to figure out what that same relationship would be out of 12. And so we know already that would be 8 out of 12. One way to think about that is 3 times 4 makes 12. So 2 times what would make X? Or 2 times 4 would make X. 2 times 4 makes 8, and so we know this has to be $8 out of 12 apples, or something along those lines. So the first word problem they give us there is that 3 baseballs, let's say. So now we're kind of flipping it. We're saying 3 baseballs is equal to $40. And so let's say we're going to buy baseballs for the school. They've given us $240, and they say go buy as many baseballs as you can. X baseballs, how many can we get? And so we're trying to find this equivalent relationship, this proportion, to figure out how many baseballs can we get. So I'm going to just simplify it down to 3 out of 40 is equal to X out of 240. Again, there's a few different ways to think about this. I can think about it as 40 times what made 240 and do the same thing in the numerators. I can also use cross multiplication, which you may have seen before, where I do my denominator on one side times my numerator on the other and set it equal to the numerator on one side to the denominator of the other. Another way I can think about it is my fraction operations. And so I showed you this a few days ago when we had the probability worksheet. So let's try one way. Let's try 40 times what makes 240. Well, I could look in my I could know this off the top of my head. I could maybe put it in the calculator. I could guess and check, but I know that 40 times 6 makes 240. So that if I do 3 times 6, I got to do the same thing in the numerator as I do in the denominator, times 6. Then I can find X. So 3 times 6 is 18. X equals 18. Let's look at some of the other options for doing this problem. We can cross multiply. We have 3 over 40 is equal to X over 240. And I can cross multiply. So you may have seen it written like this, where you kind of circle the diagonal numbers from each other. And again, we want to write that out in a way that makes an equivalent expression. And so how do I do that? I say 3 times 240 has to be equal to 40 times X, or X times 40, or 40X, however you want to write it. And so looking at this already, I'm going to have a big number on this side, and then I'm going to have to divide by 40, which makes kind of some big numbers that we don't know off the top of our head. So this way might be easier if we already recognize a common factor there, or common multiple, right? But here I can do 3 times 240 and get 720 is equal to 40x. And then we know from our one-step equations, if I divide both sides by 40, I can find x. And so x should be equal to 18. Okay? One other way to think about this, 3 over 40 is equal to x over 240. And again, I'm giving you multiple options. You don't necessarily have to do it one way or another. See which one kind of makes the most sense for you and go with that, okay? The other way to think about this, which is sort of similar to this idea here, is with our fraction multiplication. If I want to get 40 out of my denominator, I can multiply the numerator on both sides by 40 over 1, okay? And that'll get rid of the 40 over here. And if I want to get this 240 out of the denominator, I can multiply this side times 240 over 1. And 240 over 1 on this side. And notice these 240s go away. So don't go multiplying those two together because the bottom one there and the top one there make that go away. And I get, again, 40x is equal to 240 times 3. And so it would be the same thing here. I'd divide by 40, and hopefully I would get 18 again. So let's look at the example problem, which is this exact problem. So we've already worked that out. So 18 baseballs is what I can get for $240. Doesn't sound like very many baseballs to me. So go ahead and try the same thing with your practice problems. In the first one, we have 12 donuts for $6.24, and I want to know how much one donut is. So we're going to set up a proportion and solve for that. In the next one, 12 donuts cost $6.24, and I want to know how many I can get with $16.60. And then the other two are just some general problems. So take note of those, give them a try, and let me know if you have any problems.